Hi, John Hess from Filmmaker IQ, and there's no sugarcoating it. Today we're going to look at the mathematics behind blend modes found in basically all digital imaging software like After Effects, Premiere Pro, Photoshop, Davinci Resolve, as well as, I'm sure, other software platforms. You're not going to be asked to do any number crunching yourself, but we are going to get deep into functions in a 3D space. So, hold on to your butts. I admit it, I think of myself as an advanced After Effects user for almost 20 years, but frankly, I never had more than a vague notion of what these different blend modes did. I know you find them here in After Effects, here in Photoshop, and here in the opacity settings in Premiere. I probably, like you, just try out different blend modes to see what looks good and call it a day. And frankly, even after this in-depth dive today, I'll still resort to experimentation, and that's okay. But hopefully our experimentation will be more guided by a bit more understanding. Now this will require you to be somewhat familiar with basic color theory and hopefully some of the more basic mathematical functions. Now since I work in a luminous medium, I'll be focusing on the RGB color model, not the CMYK of print, although there is some obvious crossover. So let's start at the basics. What is a blend mode? Well, blending modes is how we take the pixel information from one layer and blend them with the pixel information of another layer. For this, we are going to standardize our tonal levels between 0 and 1. 0 being no value and 1 being full value. If we were working in grayscale, 0 would be black and 1 would be white. In RGB, 0 is no value in that specific color channel, and 1 is the full value in that channel. So an RGB pixel of 000 would be black. 100 is full red, 010 is full green, and 001 is blue. Combined together is 111, which is white. Now keep in mind we are using the standard 0 to 1 scale. This can translate into 8-bit, which has values of 0 to 255 for each of the channels, or to 10-bit, which has values between 0 and 1023, or any bit value. To help visualize the effect of these blending modes, let's use two squares. A base that has a black and white gradient going from bottom to top, and a blend layer that has a gradient going from left to right. Combining these squares creates an effective matrix of all possible combinations along a single dimension, be it grayscale or any one of the 3 color channels. Now notice that the corners represent all possible 0 and 1 combinations. In the bottom left, both the base and the blend have a value of 0. In the top right corner, both the base and blend have a value of 1. In the top left and bottom right, the blend and base alternate 0 and 1. The middle horizontal line of the base is middle gray, while the middle vertical line of the blend is middle gray. Where both middle lines meet in the center of the square, both the blend and base are middle gray. Now keep in mind that although we are using black and white and gray for this visualization, this chart can also represent a full value of red, green, or blue as well, but we'll keep it in black and white just to keep things clear. We will also plot these gradients in 3 dimensions. The x and y axis remain as they are, with the z axis being the luma value. A value of 1 will be higher than a value of 0. You'll notice that the gradient isn't perfectly linear in the z-axis. I believe this is because the gradients created by Photoshop and After Effects aren't perfectly linear to begin with, and because 3D Studio Max also added gamma when creating the relief map. It's a detail that I think doesn't really detract from understanding the point of the demonstration, and may actually more accurately represent visually what is happening. Let's take a look at the very first set of blending modes, normal. The typical normal behavior of 2 layers is the layer on top covers up the layer beneath it. We can notate it like this. So the function of A, which is the bottom layer, and B, the top layer, is just B. Now, if the B has an alpha channel, the channel which controls the transparency of that channel, we could write it out like this. That means where the top layer B, as defined by its alpha, is shown over the lower layer A. Before heading into some more mathematically tumultuous waters, there are a couple blending modes left in this normal section. The first is Dissolve. Dissolve randomly chooses pixels between the base and blend layers. In Photoshop and After Effects, the opacity of layer B determines how many random pixels are picked from that blend layer. The lower the opacity, the fewer pixels from layer B are used. Now, since this is a static blend mode, After Effects has the option of Dancing Dissolve, which randomizes the pixel selection over time. In Adobe programs and probably other imaging programs, blending modes are divided into groups. Let's explore the first two groups, Darken and Lighten modes. The first mode is a simple mode called Darken. Darken takes a look at the two layers and retains only the darker channel value. Notice how the square of the blend is essentially cut in half diagonally. Anything that's below the diagonal is essentially the base. Anything above the diagonal is the blend layer. And notice the prominent diagonal line. This transition is pretty distinct here. The opposite of Darken is Lighten. Lighten retains only the brighter of the two channel values. Again, notice how the blended image is essentially cut in half by the diagonal. But this time, anything that's below the diagonal is the blend, and everything above the diagonal is the base. Now, just pointing this out, that diagonal I'm referencing exists in the blend only because of the nature of the gradients in our base and blend. The visible diagonal represents the hard transition the blend mode makes when confronted with two gradients. When darkening, whatever channel value is darker, it takes that value. When lightening, whatever channel is lighter, it takes that value. Let's extrapolate that out into a practical example. Here I have a red box on top of a face. When using darken blend modes, After Effects compares each color channel and picks the darker one. This spot on her face, it picks 220, which converted to standard is 0.86, then 0 and 0. When over the cyan background, it picks 0, 0, 0. Let's flip it to Lighten. Now the dark areas of the image, like her hair and her sunglasses, get converted to red, while the cyan background shifts to something more pink. So with Darken and Lighten, you will see shifts of color. Now, Darken and Lighten have one alternate effect called darker color and lighter color. Instead of basing the decision on each channel value, darker color and lighter color look at the composite and pick only the darker or lighter color composite, respectively. Here is our practical example, again with darker color. Notice how the box is fully red except in the shadows, which are darker. Flipping over to lighter color, notice how the dark shadow areas, the hair, and her sunglasses, are red, where everything else retains its original color. Because of this hard transition, Darken, Lighten, darker color, and lighter color aren't usually used for blending. That honor goes to the following two, Multiply and its opposite, Screen. Multiply is pretty straightforward mathematically. You take each channel and multiply them together. Now, since a fraction less than 1 times a fraction less than 1 always yields a fraction smaller than either of the original fractions, multiply will always darken the image. Notice that the upper left and bottom right corners are black because black is 0 and anything times 0 is 0 regardless of whether it is in the blend or the base layer. On the flip side, white, being a value of 1, will have no effect on the blend in multiply mode. Screen, the opposite of multiply, is a little more complicated mathematically. The inverse of a tone is 1 minus that tone. Screen takes the inverse of the base and blend layers, multiplies them together, and then takes the inverse of that value. Now white dominates because its inverse is 0, and when you take the inverse of something times 0, the answer is always 1. You see white dominating the upper left and the bottom right corners. On the flip side, black, with a value of 0, gets inverted to 1, which gets flipped back to 0. In other words, black will have no effect on the blend in screen mode. In fact, all modes in the Lighten group will be unaffected by black, and all modes in the Darken group will be unaffected by white. Screen mode is really useful for blending light effects like light leaks, barrel blasts, explosions, anything that generates light. Multiply mode is useful when you're trying to blend something darker on an object or for creating shadows. The next darkening mode is color burn. Now, color burn takes the base image, inverts it, divides it by the blend layer, and then inverts the result. The opposite found in the lightening group is color dodge, which is the base layer divided by the inversion of the blend layer. A color dodge and color burn essentially replicate the look of dodging and burning an image. With color burn, you get more saturation in the midtones and reduced highlights. Color dodge also increases the saturation in the midtones, but blows out the highlights. Color burn and dodge are also members of the Special 8 blend modes, where there are two ways to control their effect: opacity, which is used for all the blend modes, and fill. In After Effects, it can be a little tricky to find fill. You have to go into layers, layer styles, show all, and then you'll find the fill opacity in the advanced blending. Here's how the shape of the blend in 3D changes using the opacity versus fill with color burn. And here it is with color dodge. For practical application, let's apply a horizontal black and white gradient to our practical sample to see what happens with color burn and color dodge. With color burn, you see the left side going to black and the model's skin tone's way saturated. With color dodge, we see the opposite side going to white, but still that same saturation, although it's hard to see and everything is all blown out. Now, toning down the fill opacity will create something that is more useful for everyday projects. To see how colors shift, let's apply a red-yellow gradient and see what happens. Using color dodge, the left side of the image goes completely black. Going back to our equation, this makes sense because the inverse of the cyan background is red. Red divided by red is 1, so 1 minus 1 is black. Switching over to color dodge, we get this result. This is covered with lots of little noise because yellow is full red and green. This cyan background has very little red, so 0 red. Going back to our graph, we're in this jagged section where the math starts to break down as you're having essentially 0 value divided by 0. The solution to this is to pull down the fill a bit to prevent the numbers from going over the edge. In After Effects, there is a classic version of both color burn and color dodge. Those are the same visual effect, but a legacy version for older projects that might still use them. The final yin-yang pairing in the Darken and Lighten modes are linear burn and linear dodge. Those of you After Effects aficionados may have noticed that I skipped add. Well, that's because every source on the math I've been able to find says that add and linear dodge are the same thing. You take the values from the base layer and you add them to the blend layer. This will always result in an image that is brighter than the original image, and in the case where the sum is more than 1, we just cut it off at 1, full white. The inverse of add or linear dodge is not subtraction. That's another mode for later. It's simply the sum of the two layers minus 1. And here every value below 0 is replaced with 0 black. Linear dodge and burn have similar characteristics to color dodge and burn, but as their name implies, the characteristic is much more linear. And there's not the kind of saturation you get with color dodge or burn. As with color dodge and burn, linear dodge and burn also behave differently with the fill and the opacity, as you can see here. Because linear dodge and burn doesn't have this asymptote shaped curve at the extreme ends, it can be more useful for an overlaying text. When color dodge and burn can lead to some bizarre and ugly transfers with some oversaturation, linear dodge and burn are pretty predictable to the eye and have more contrast than multiply. The next set of modes are the contrast modes. Where white had no effect in the darken modes and black had no effect on the lighten modes, it is middle gray that has no effect in the contrast mode section. To see how this plays out, let's look at the first contrast mode, overlay. Overlay is a combination of two other modes we just discussed: multiply for the tones below middle gray and screen for the tones above middle gray. Overlay is the only contrast mode that actually looks at the base layer in order to determine which mode to use as a blend. Now notice the middle gray line on the base layer. If we transpose this line to the blended version, we can easily see how the pattern above middle gray is the same pattern we had for screen, only squished. And the pattern below middle gray is the same thing we had for multiply, again, squished. Overlay is what's called a commuted blending mode. Commuted blending modes are modes that are related to each other based on the order of the layers. Overlay is a commuted blending mode to hard light. Here you see hard light has the same math, only instead of using the base layer, it uses the blend layer as a reference for middle gray. The difference in our gradient sample is the middle gray line runs vertically. On the left side, or darker side of the middle gray, you see multiply. And on the right side of the middle gray line, you see the pattern for screen. The hard light mode would yield the same results as overlay if you switch the blend and base layers, which makes sense because the only difference between overlay and hard light is which layer is referenced for middle gray. Overlay and hard light are good for applying textures to an image, especially something that has both light and dark elements to contribute. I found this paper texture. Now this is a little bit too bright to work as an overlay because remember, it will multiply the highlights and push everything toward white. So I use curves to bring the texture down to more in the realm of middle gray. Now watch what happens when I use overlay. The texture gets applied rather pleasingly to the image. It takes on the paper texture better than either multiply or screen. And also because overlay samples the base layer always comes through. Let's switch it over to hard light and you'll see that the paper texture actually comes through stronger. It's almost like a transparent sheet of paper was put on top of the image. The next mode in the contrast group is soft light. You might think that soft light is related to hard light because of its name. Well, it isn't at all. In fact, here's the formula for soft light, which is some sort of quadratic function. Best I can tell, it is the multiplication of A and the inverse of B plus B, all of that again multiplied by A when the values are below middle gray in the blend layer, then the inverse of that when the values are above middle gray. There are several other similar formulas used by other software applications. This one is the one used by Photoshop since 2012, but does have a local discontinuity of contrast based on gamma values that's corrected in other software applications. That's all I'm going to have to say on that topic for now. Information on this is a bit hard to come by, and it's a little too in the mathematical weeds even for me. Point is, soft light sort of emulates overlay, but in a much softer way. As Adobe describes it, the effect is similar to shining a diffused spotlight on the image. Black and white from the blend modes will never fully turn the blend black or white. Soft light can be used in a number of ways. To add some punch to your shot, you can simply duplicate your base layer and apply soft light to the duplicate layer. You can use soft light to relight or give a soft vignette using gradient maps. White on the blend layer will brighten the base layer and black will darken. You can use soft light to gently add color cast. You'll see a lot of orange and teal at work here because, hey, it actually works and looks good. But there's lots of ways to subtly apply interesting color combinations using soft light. Here's a 4-color gradient applied to a beach scene using only soft light, which I think brings the footage to life if you're going for a warm, cozy look. The next few contrast modes are kind of extreme cases. Linear light, as you might have guessed, is the combination of linear dodge and linear burn. Vivid light combines color dodge and color burn, and pin light combines darken and lighten. Vivid light and linear light are also part of the Special 8, which can be controlled by the fill as well as the opacity, and you can see different effects here. Generally, you want to set the fill to about 50% of these three, as they do give you a little too extreme a look at 100%. To me, linear, vivid, and pin light aren't as useful for creating naturalistic blends, because you'll end up dialing them so far back that you might as well just use soft light or overlay. But if you are going for a truly out there look, hey, give them a try. The final contrast blend mode is a strange one called hard mix. This one's a bit hard to explain. First, it is based on linear light blends, so middle gray doesn't affect it. Once linear light math is done, each channel is then converted to either 0 or 1, on or off, resulting in only 8 colors allowed possible when the blend mode is in full fill opacity: white, red, green, blue, cyan, magenta, yellow, and black. You can best see it in this color wheel sample. Watch as I apply a middle gray layer with a hard mix. The result is a pattern which only contains those previously mentioned 8 colors. Now watch as I change that hard mix layer, increasing the brightness to white and then lowering it back to black. Changing the colors also creates interesting, nifty patterns and shapes. As I mentioned, only 8 colors are allowed when this blend mode is in full fill opacity. Reducing the fill opacity increases the number of colors allowed. Now, as for practical application, hard mix is basically an extreme version of linear light. For color grading and recoloring purposes, I think you're better off just using linear light. Now, there are some graphic design uses for hard mix, as you saw in the initial explanation. If you hard mix a noise layer with a black and white base, you can create an interesting pointillism effect. You can even get reasonable halftone dots using a blurred checker pattern hard mix over a black and white footage. And now we come to the last of our mathematically based blending modes, the difference modes. These modes, as the title suggests, look at the differences between the blend and the base layer. The first one is difference, and it's just the absolute value of the base minus the blend layer. When you apply the difference mode to a blend layer that is the exact same as the base, you get black. This is useful for trying to align the same object from different shots. Otherwise, the difference mode will tend to create a negative effect when either the base or blend layer are white, and allow the other layer to show through when either the blend or base layer is black. Difference is also one of the special 8 that has different fill and opacity effects. Classic difference in After Effects is basically the same, but with a legacy code. The next mode is exclusion, which is a linear dodge minus 2 times the multiply effect. As you can see, the shape of this is very close to that of difference, except that the value between the 2 white corners never gets all the way down to black. In fact, middle gray in either layer will always return middle gray. Black in the blend layer will have no effect, whereas white in the blend layer will invert whatever is in the base layer. The result when applying to a color layer using exclusion blending is the dark regions will take on the blend layer color, whereas the light parts of the image will take on the inverse of the color. Artistically speaking, its most practical effect is when you apply a blue layer with exclusion. The skin tones, because they tend to be higher, will become blues opposite of yellow, and the darker parts of the shots will take on some of the more blue. But both difference and exclusions can be used for more extreme pop art styles. The next 2 modes were designed for calibrated imaging systems, but they do have some artistic application. Subtract is pretty straightforward. It's just the base layer minus the blend layer. Subtract can be useful for adding or taking away color casts. Here's the original footage, has a greenish cast to it. Applying a solid with a color of 0.080, subtracting 0.08 green from the entire shot, leaves what I think is a more pleasing color. You can even introduce different color casts by adjusting the mix, and notice that the values used here are very low. Anything higher will result in subtracting all of the image. The final mode in difference group is divide, which you may have guessed divides the base layer by the blend layer. Here, white is the neutral color, as anything divided by 1 is 1. You can also use this mode to correct color casts, only here you would use a color that's closer to 1. Okay, that does it for all the mathematically based blend modes, but there are a few more blend modes in After Effects and Photoshop worth covering, and we'll run through those briefly. The first section is the HSL section. Basically, this section replaces the hue, saturation, color, or luminance of the blend layer with the corresponding attribute in the base layer. So if we select hue, we keep the hues of the blend layer, but take the saturation and luminosity of the base layers. If we select saturation, the result will maintain the saturation of the blend layer, but take the hue and luminosity of the base layer. If we select color, we keep the hue and saturation from the blend layer and only take the luminous data from the base layer. If we select luminous, we only take the lumina data from the blend layer and take the hue and saturation from the base layer. HSL blend modes are useful in recoloring shots and used extensively in turning black and white images into color. After HSL are stencil modes. Stencil alpha means every layer below will take on the alpha of the blend layer. Stencil luma does the same thing, only instead of looking at the alpha layer, looks at the brightness of the blend layer. Silhouette alpha and luma do the inverse. Finally, the last 2 blend modes of After Effects are alpha add and luminescence premol. Alpha add changes the behavior of alpha channels when layered on top of one another. Instead of performing a second alpha calculation, alpha add adds the channel's alpha to the alpha value underneath it. This is useful when you have layers that are touching where anti-aliasing can create some weird seams between layers. Luminescent pre-multiply is a utility to correct clipping of color values that exceed the alpha channel value after compositing. This is mainly used when you have light effects in footage with its own alpha channel coming from a different matting software. And there you have it, a conceptualization of all the blending modes found in After Effects and most image manipulation software. With digital imaging, there's multiple ways to skin a cat. And hopefully this exploration of blend modes gave you a few extra ways to accomplish what it is you're after. If you like this video, hit the like, subscribe, and ring that bell. Consider becoming a patron on Patreon so I can give you more insight and deep dives in this fascinating world of filmmaking. Special thanks to our A-Team patrons. You guys are the best. Check out our merch store in the shelf below, and thank you for watching. And now, my friends, go out there and blend up something great. I'm John Hess. I'll see you at filmmakeriq.com.